understanding the part that you want to understand is finding the needle in the haystack.
We should say that the Transformers library has like 400 models.
So it's a one library that tries to implement a lot of LLMs, and so you have a huge code base. Basically, it's like huge. It's like it's, I don't know, maybe millions,
It's
hundreds of
crazy.
thousands of lines of code, and it's like understanding the part that you want to understand is finding the needle in the haystack. But what's beautiful about it is you have a working implementation, and so you can work backwards from it. What I would recommend doing, or what I also do, is if I want to understand, for example, how OLMo 3 is implemented, I would look at the weights in the model hub, the config file, and then you can see, oh, they used so many layers. They use, let's say, group query attention or multi-head attention in that case. And you see all the components in like a human-readable, I don't know, 100 lines of config file. And then you start, let's say, with your GPT-2 model and add these things, And the cool thing here is you can then load the pre-trained weights and see if they work in your model. And you want to match the same output that you get with a transformer model, and then you can use that basically as a verifiable reward to make your architecture correct. And then it's kind of, sometimes it takes me a day to, with OLMo 3, the challenge was rope for the position embeddings. They had a yarn extension, and there was some custom scaling there, and I couldn't quite match these things. And in this struggle, you kind of understand things. But the cool thing is, at the end, you have it correct because you can unit test it. You can check against the reference implementation. And I think that's maybe one of the best ways to learn, really, like to basically reverse engineer something. Yeah.